Welcome back, guys, to the next session of data structures cohort by Fluxus. Okay, DSF cohort by Fluxus. My bad. So, till now we have discussed various data structures like arrays, linked lists. We have also had various sessions on time complexity, master theorem, and all. So today we will start with the first data structure. Okay, let me put it as key a data structure which will start a series of data structures from now, which can be typically called a data structure. Okay, arrays and linked lists were a data structure, but they are mostly used to implement the other data structures. Okay, from now on we will start with data structures that have their own property. Okay, so let's start with today's session, that is on stack data structure. Okay, yes, dynamic. The course is taught using C++ as the primary language. Okay, and wherever it the need be, I also mentioned okay, how what are the changes that are required for Java, Python, and all other stuff. Okay, so let's start with today's session. So today's topic is a stack. So what is stack? Okay, so stack in general is nothing but a pile of things. A pile of things. The literal meaning of stack is a pile. Okay, suppose I keep on keeping my books over each other and create a pile of books. So this will only be my stack of books. Okay, now as we were discussing data structures, so we will not go into the literal meaning of things, we will go into the properties of this data structure and why is data structure necessary. Okay, so stack data structure is nothing but a data structure that stores data in a linear fashion. That means it is a linear data structure. Now, it is a linear data structure, but what it does is it stores data in linear fashion. That is what the meaning of linear data structure, like arrays and linked lists. Those two also were linear data structures only. But what's the difference here is, or what is the unique point here is that stack data structures. Okay, suppose I'm trying to enter some numbers here. Suppose the numbers are 1, 2, 3, 4, 5, 6, 7, like that. Okay, what I'll do is I'll pick one number and put it into this stack. Okay, so this operation is known as pushing element into the stack. This particular operation, that is to put an element into the stack, is known as pushing the element into the stack. Okay, so this is one of the property, this is one of the functions that can be implemented over a stack. That is a first function is the push function. And what the push function does, it basically inserts the element. It inserts the element. So how it will be inserted, it will be inserted in this fashion. One will be inserted, so one will fall down to the stack. Now 2 will be inserted, 2, 3, 4, 5, 6, and 7 got inserted in this particular stack. I think no problem still here. Okay, okay, now now this was one of the operations. What I did is I just took an array of numbers, or say a list of numbers, and what I did is I just pushed them into the stack. And what is pushing, I am just inserting the elements, adding the items in my stack. This particular function that is implemented on a stack is known as push function, and what it does is it just inserts, adds the uh, numbers in the array, in the stack. Now suppose I have one more element here. Let's suppose it is 8. Now what will happen, I will try to do, let's say, something known as push 8. What I'm trying to do, I'm trying to push 8 into the current stack. So what will happen, no places are vacant now, the stack is full. What is happening here, the stack is full. So what will happen if the stack is full? So what will happen is no new elements can be inserted, no new insertions can take place, insertions can take place. So what will it do is it will throw an error, and that error will be known as overflow error. So what is the technical term? Okay, So what is overflow? Overflow is the technical term of the phenomenon when we try to insert an element, when we try to push an item into the stack and the stack is already full, okay, filled to its maximum capacity, then such a phenomenon is known as overflow condition. We are trying to overflow this stack, so the element cannot be inserted. So it will not be inserted because overflow condition will be reached because the stack is getting filled here. This is the highest limit of the stack. Only 7 elements can be inserted here. Okay. Now there is one more operation that can be implemented on stacks, and that operation is known as pop operation. And a function, the second function that can be implemented on a stack is known as pop. Pop is nothing but pop is deleting the elements. Pop is deleting the elements. So what is happening is pop, what does pop does? Pop removes the element from this current stack. It is just the opposite of push. What was push doing? Push was just inserting the element into this stack. And what is pop doing? Pop is uh, removing the element from the stack. Okay. So suppose what I did is I did keep pop, and as this is a stack, the stack follows something known as a LIFO principle. What does stack follow? Stack follows LIFO principle. Well, what is LIFO principle? LIFO principle is last in, first out. What does stack follow? Stack follows a principle named as LIFO. And what is LIFO? Last in, first out. And what does it mean? It means that whatever element was inserted the last into the stack will be the first one to be removed from this stack. So if I do a pop operation now, on this particular stack, what will happen? So what will happen is this particular 7 will be deleted, will be removed from the current stack. Why 1 was not inserted? Why 1 was not removed? Because 1 was the first one to get into, and stack does not follows first in first out, it follows last in first out. The element that was last to get in will be the first to be popped out. Okay. Now suppose I again do a pop operation. So what will happen? Now 6 will get away, now 5 will get away, 4 will get away, 3 will get away, 2 will get away, 1 will get away. Now suppose at this stage the stack is already empty, the last element has already been popped out from this stack. Okay. So now suppose I again try to pop from this stack. So what will happen? There is no element present in this stack as of now, and I'm trying to pop elements from this stack. Okay. So it will throw an error now. And what error it will throw? It will throw an error known as underflow. Opposite of overflow. What was overflow? Overflow was when we are trying to insert elements into a stack and the stack has been filled with its maximum capacity. And what is underflow? Underflow is when we are trying to delete, when we're trying to pop elements from an empty stack. Okay. So this is what is underflow. Now let's restore the original structure of this stack. Okay, this is the original structure of the stack. There is one more operation known as top/seek. Java developers may be familiar with seek operation. Sorry, seek, I said peek. Sorry, my bad. It is known as seek, peek, anything you can tell it. Top, peek, and also seek is also there. No mistake. Okay, so what is this peek, top, or seek? Okay, see what push does is push inserts the element into this stack. Okay, what pop does? Pop removes the element from this stack. Okay, what top or peek or seek operation does is it prints the element that is present at the top of this stack. And what is the top of this stack? You can say if I do a pop operation now, if I just do a pop operation now, which element will be there to get out from this stack? 7. So what will top return is top will return 7. So you can think it in this fashion as whatever element will be popped out now will be returned using top function or seek function or peek function. All three are the same things only. Okay. So top returns the element present at the top of this stack, or at the end of the stack, or at the last of the stack, or the element that will be deleted if I do a pop operation. Now that particular element is returned using top of the uh, top function of the stack. Now one more function that can be implemented on this stack is, see, one was top function to return top element from this stack, to return top element from the stack. Now now one operation that can be, one more function that can be implemented on this stack is empty operation, is empty function. And what will it check is, this function will check whether my stack is empty or not. Okay, if the stack is currently empty, that means my pop will return an underflow. Okay, so that thing can be checked using the is empty function. Is empty just checks whether the stack is empty or not. So the current status, the stack will return is empty as false, because the stack is not empty. Okay, but this particular stack will return is empty true. This will return true, and suppose there are elements in this stack, so it will return a false. Okay, so this is all about the theory of stacks. One is the overflow, let me write it again, and another was underflow. Maximum limit crossed. Okay, and this was key empty, basically empty, the stack is empty. Okay, we are trying to delete elements from an empty stack, then it is known as underflow condition. We are trying to insert elements in a already full stack, then it is known as overflow condition. I think this is clear. Okay, this is all about stack. Stack follows last in first out principle. The element that is last to get into will be the first to get out. There are four operations that can be implemented on a stack, that are push, pop, top, and is empty. Push means to insert and add an item to the stack. Pop is delete an item from the stack. Top is return the topmost element from the stack. Okay, and is empty checks whether the stack is empty or not. Okay, now there were two kinds of error, overflow and underflow, that we need to check. Overflow means when we are trying to insert elements in a full stack, and underflow means when we're trying to delete elements from an empty stack. Now the next thing that we need to take care is, how is stack implemented in any language. Okay, so stacks can be implemented in two ways. One is using arrays as the base data structure, that is, we'll use arrays to store the data. Okay, and we'll implement the four functions, that is empty, top, pop, and push functions on this array to resemble a stack. Okay, second one is we can also implement stacks using linked list. Okay, in the similar fashion, we will use a linked list to store the elements, and then we will implement the four functions, okay, to replicate the properties of a stack using the linked list. And the third one is language specific tools that are available in C++ and Java. That is, we have an stack STL. Okay, that I already used in the last session while we were solving one question on the linked list, that was reversal of a linked list. So we can also implement or use stack, but by directly using stack STL. So we'll now move on to the discussion of how to implement a stack using arrays and using linked list. Okay, then we will solve some problems on stack, and therein we will be using the stack STL. Now one more important funda is why we generally use stacks. See, if the element to be pushed into a stack is 1 2 3 4, if the element to be pushed into stack is 1 2 3 and 4, so while popping out, what will happen is, first element to be popped out will be 4, second element will be 3, third element will be 2, and the last element will be 1. So what is happening is, as you can clearly see here, the elements are popped out in the reverse function, in the reverse order, as in they are pushed in. So this is one of the fundamental use cases of stack, that is to reverse something. Okay, in the last session also we used stacks to reverse a linked list. So that is where stacks are generally used to whenever we need to reverse something. Just keep in mind, if reversal is there, whenever you need to store some items and remove the items in the opposite order, in the reversed order, one thing must click your mind is that we need to implement stack of some kind here. Stack of some kind here. Like in the last session we discussed a problem where we needed to reverse the linked list. So what I did is I just implemented a stack storing the nodes, okay, stack of type node, and then just pushed every node of that particular linked list into that stack and popped out this stacks. Okay, okay. So this is the thing that is stacks are generally used for, to reverse things. Okay, now let's move on to the implementation of stacks using arrays and linked lists. Now, one more thing. What are the time complexities of the various operations that we discussed here? As we can see here, that push operation just traverses the linked list once and pushes the element into the into the last position. What pop does, pop just takes into the moves on to the last position and pops out there, deletes the element. Top does, top just moves on to the last position and prints the element. So all these operations are taking just constant time. Okay, so all these operations take just O of one complexity, have constant complexity. Okay, because we do not need to traverse. If somebody is saying O of n, no, O of n, because whenever the complexity is O of n, a traversal is there. Okay, we need to traverse the whole data structure. Here no traversal required. Why? Because we are only dealing with this particular position. Whenever we are deleting the element, we are just moving going to this particular position, the last position, and deleting the element. Whenever we are inserting, we are doing the same thing. We move on to the last position, insert the element there. Whenever we are for returning the top of the stack, what are we doing? We are just moving on to the top position and just printing the element there. So all these operations do not require any uh, traversal of any kind. That's why the complexity is O of 1, that is constant complexity. Okay, so now let's move on to the next thing, that is implementation of stacks using arrays and using linked lists. Okay, chalo. End out still here? If not, then we'll move on to the implementation of stacks. I think nobody has any doubt, so we'll just implement the टाइम कॉम्प्लेक्सिटी क्या होगी स्टैक की O of 1 dynamic. Okay, as no doubts are there, we will just move on to implementing the everything dynamic. Pop, push, everything will take just O of 1 constant complexity 1. So let me just fire up my term ID, then we will move on to no Ravi, why it will take O of log n according to you? Can you please explain? See what is happening. Even though it is insertion or deletion or just print seek operation, what I am doing, I'm just moving on to the position that is stored in the top. Okay, top stores the position of the last element. What I do is, if top stores the position of the, suppose top stores the value 5, that means the last element is present at 5. So what I will do is, if I have to do push, what I will do, I'll just increase the 5 to 6 and insert the element there. If I have to delete the element, what I will do, I'll just delete the element at 5 and decrease the top value to 4. If I have to do a top operation, what I will do, I'll just say key whatever element is present at 5, print it. So all these operations, what I am doing, I'm just moving on to just array of 5 and doing my task. So all these things are requiring what? It is just requiring a constant time. Okay. So I don't think deletion will take. See Ravi, I think you are confusing here. Ki, see, while deleting or while popping, we do not pop specific elements. Which, like, we are not saying ki pop out 5 from this stack. Then it will have to search the element and then delete the element. So searching will take some time. And then if I implement binary search there, then it will take log n. But in general, what pop means that delete the element from the top of the stack. We are not interested in the value of the stack, value of the element. We are just interested in deleting the element. Okay. Okay. So let me just create some folders here, and then we'll just. Okay, my bad. Sorry. अरे जाना यही तो बनेगा क्या दिक्कत क्या और इसको अरे okay. So let me just start off now. So do you want to this for okay, no problem. Let me delete all these files. No, not required now. So I just need this. So what's the first thing that I need while implementing it using an array? So first thing I'll need is an array that is named as stack. Okay. So let me first implement in this simplistic manner. Okay, that is, I'll just use an array and implement all the functions on that particular array. Okay, and to just show how an array can be used to implement a stack. Then I'll just move on to implement stacks using a class variable, like we are comfortable you with use it, like we did in linked list and all. Okay, so first let me just implement it in a simplistic manner, then we'll move on to the class implementation of a stack. So the first thing that I need to do here is first thing that I need to do here is I need to import some header files. So as I have already told you, if I include this particular header file, I do not need any other. Okay, now using namespace std. Again, what I need to do here is, okay, I'll just declare some global variables out here. Okay, so first global variable will be a stack array, will be my stack array. So let's define this stack array to be of size 10. Okay, so that I can also show you how underflow and overflow might work. Okay, so and then I'll declare also the size of the array as a separate variable, no big deal. And what I can do is okay, so if no element is stored here, currently the stack is empty. So what will happen if my see what is happening? Currently the stack is empty. Okay, I have just declared a stack. I have just declared a stack of size 10. So what I am doing is I'm just declaring a stack of size 10. Currently no element is there. That means the stack is empty. If the stack is empty, okay, so what will happen? If I do a pop now, what will happen? It will throw a underflow condition, underflow error. If I do a push, the element will be inserted at the first place. If I do a top, what does top return? Top returns the first the element at the topmost position. If there is no top, if there is no element at the topmost position, the stack is currently empty. So in this case, what will happen is top should be behind the array. There should be no top because no element is only there. So what I will do is I know that array indexing starts from 0. Array indexing starts from 0. So what I will do is I'll just make my top as -1. If my top is -1, what does it mean? It means that uh, array indexing has not yet started. Array indexing has not yet started. So this is also I will define in my global variable itself as top equals to -1. This is what top equals to -1 means. This means that my current element, the current array indexing has not yet been started because no element has yet been inserted in this particular array. And what is this particular array? This particular array, we are trying to mimic this stack data structure. Now let me just define the various functions that we can implement on a stack data structure. First one will be the push. And what will push require? Push will require one item that it needs to be pushed in the array. Now what's the next function will be void pop. And what will pop require? Pop will not require anything because we are not passing the position or the element that we need to pop. Pop just means keep pop out the last element from the stack, so it will not require any parameters. Now the next element that the next function that we need to basically make is void top. What's the top element of the stack? And just like pop, top also returns the element at the top position, so it is also not requiring anything from my side. And what will pop do? Pop will return a value. Okay, so what value it will return? It will just return the value that is stored in the arrays. It will return an int type value, the element that is present in the stack. And one more thing that we now return, we now need to make one function that is empty function. And what does this empty function do? It just checks whether my current stack is empty or not. So these are the different functions that we need to implement in our current discussion. Okay, I think no doubt still here. I'm just making. So now, while pushing the item, what will happen? What will happen while pushing the item? While pushing the item, one thing can happen is that the current element that the current stack in which I am trying to push the element is already full. Okay, that is, it has reached the maximum capacity. And if that particular stack has already reached its maximum capacity, we know that that particular condition is known as overflow condition. So first we need to check that. So what I will do is I'll just check using an if construct, that if my current top, value of my current top is n minus 1. Why n minus 1? Because n is the maximum capacity. Index n will start from 0. So the last element will be stored at the index 9. Okay. So if my top is 9, okay, that means no element can be inserted because the array is already full. And if my top is 10, that means the array has already been filled in the last iteration. So both of these conditions are because the stack is overflowing. So that's why what we will do is I'll just return an overflow here. Overflow here. Okay, I think no doubt still here. Why I'm just displaying an overflow here. Okay, if it is not overflowing, so what will happen? I just need to add that item to my current stack. And for adding the item for my current stack, what I will do, I'll just increase the top. If my current top is 4, what I will do, I'll just increase the top to 5, because till 4 the elements are there. Okay, the new element needs to be inserted in the next position. So what I will do is I'll just increase my top by 1. Okay, I'll just increase my top by 1. And in the next iteration, what I will do, I'll just make that at the current position of my top. What I do, you just insert the item. Okay, so this is all about the push function. What I am doing, I am receiving an item as a parameter. Then I'm checking the overflow condition. What is the overflow condition? If my top have already exceeded the maximum capacity of the array, or is trying to exceed the maximum capacity of the array. In both the cases, I am displaying an overflow. If overflow condition has not yet been reached, so what I am doing, I'm just increasing the top and inserting the element at that particular position. So this way, push function has been implemented. Now let's try to implement pop function. So now, how to implement the pop function? As we checked the overflow condition in push, let's suppose that the array, the stack that we're trying to pop the element from does not contain any element as of now. That means the stack is empty. So in that case, if I'm trying to delete the element, what will happen? It will throw an error, and that error should be an underflow error. So what I'll just check is, if the array is empty, what is happening? If the array is empty, the top, I know that I have initialized the top as -1. And if the value of top is still -1, what does it mean? It means simply that the top, no other element is present in that stack, because the stack indexing has not yet been started. So what I'll do is I'll just print a underflow here. Underflow here. Okay, now if the stack is not empty, that means there are some elements present in that particular stack. What should I do? I will have to remove the element. So what I will do is I'll just print out the element that I am removing. So what I will do is I'll just print that popped element. Popped element is, I'll just print this particular thing here, and then what I'll do is I'll just mention what to print. And what to print is whatever element is pointed to by the top now in the particular stack, you print that. And in the next step, what I'll do is I'll just decrease the value of top. So what will happen? top will not point to that, to the element that is of pointing to currently, and that I have reduced the top. And what is happening? See what is happening. Let me just draw it and show you. See what is happening. If suppose this is my array, okay, elements were stored something like this at 0, 1, 2, and 3 and 4th position. What I'm doing here is, if I have executed a pop function here, what will happen? It will go to the top. And where is top now? Top is at 3rd position. So what it will do is, it will just print stack cut top. And what will be printed? 4 will be printed. Okay, now what I am doing is, I'm just reducing the top. So if I am doing top equals to top minus 1, what is happening? Current top was at 3, it will do 3 minus 1, it will get 2. So what will happen? Top will not point to this element, top will start pointing to this element. So what is my stack now? Stack starts from here and ends here. So what is the elements of the stack? The element of stack is now currently 1, 2, and 3, because 4 is not pointed to my stack now. So this is what I am doing here. This is only what I am doing here. Any doubts still here? Now let me just check, create the uh, top function. And what will top return? Top will just return the element pointed to by the top. So what it will do is, it will just return my stack cutoff. Just a simple thing here, nothing much. So what is bool is empty check? Bool is empty will check whether my stack is empty or not. And I already know from the pop function, if the stack is empty, what it will do is, it will just check whether my top is -1 or not. And if the top is -1, what it does, it returns that the stack is empty. So what I'll do here is, actually, let me just make it something like this. If this top is less than 0 only, less than equal to -1 is not needed. So okay, what I'm okay, I just need to, oh, okay, is empty may I need to implement it. So what I'll do is, I'll just return if my top is less than 0 or not. Why? Because if top is less than 0, it will return truth. Okay, and if it is returning truth, that means the array is empty. If any element is there in my stack, so what will happen? Top will not be less than 0. So what will this will return? This will return a false. And if it is returning a false, then what this means? That means my stack is not empty now. Okay, one thing I made a mistake here, that while implementing top, also I need to check whether my stack is empty or not. Because if the stack is empty, then I need to return that underflow condition. So what I'll do is, okay, I'll just implement it using an if statement here. I'll just check if I can also use the is empty function now, but I'm not using. Okay, just because it will be get confusing for you if I'm using functions calls inside function calls. So in this condition, what I'll just print key. See, you are trying to get the top of an stack which is already empty. So just print empty stack. Now, if this is not the case, the stack is not empty. So what you do just this thing. You just return the value that is particularly pointed to by the stack. I guess nobody should have a doubt till here on these particular functions. Is full is not needed dynamic. If I am already checking is empty, okay, so there is no need. I'll just try to. If you can also define a useful function, but there is no need of it. You can define. There is no such thing that you should not define it. If you want, you can define it. So what will happen here? I just need to call the different functions. So let me just create one simple thing. Let me just create a switch construct here. Okay. So let me just check this create so that I am able to call different things here. Okay, so let me just do this thing now. Now what I'll do is I'll just okay, let me just print out the different options. Options. Okay, what are the different options? Let me just check it. If I am entering one, I need to push. If you are entering two, you want to pop. And if you are entering three, what was the third that I implemented here? Pop, push, pop, top. Okay, yeah, what I did. See, in the third one, what I am checking, I'll just check whether it is empty. Okay, let me just return the top here. The next option that I will provide is whether my stack is empty or not. So fourth option will be used to check whether my stack is empty. Now what we can do is I can also implement one more function here. One more function will be to print stack. We'll just okay. I guess this is clear. I'm just creating a switch construct here, nothing else. So let me just first of all create one more thing, that is printing the stack. So what I'll do is I'll just print stack. So what it will take, it will not take anything. Okay, what it will do, it will just check. First of all, it will check whether my stack is empty or my stack is full. So let me just print if top is greater than 0, that means the stack is not yet empty. So what you need to print is you just need to print you just traverse the stack, you just traverse the stack, and then okay, not top 0, it will be top. And as it is an array, top will always be at the greater indexes, so I needed to traverse the array in the opposite direction, and I'll do I minus minus here. Okay, so now what will I do, I'll just do is I'll just print out the stack elements. So I'll just print out stack element at position I. Let me just print out a space here. Okay, i guess I guess this will work. And at the end of this loop, what I'll do is I'll just print an empty line. So to change the line, okay, and the printing statement. And one more thing I need to check, if top is not greater than 0, so what will happen is my stack will not be empty in this case. The stack will be empty at this case, means this is the underflow condition. So I'll just print underflow here. I'll just print an underflow here. Okay, I think this is clear to all of you. I'm just traversing the top. Okay, and Array, one more thing. In C++, stack cannot be used for the naming. So let me stack one. I'm just making it as stack. What? Sure. I think this should work now. Why it is giving me such a... Chal. No, no proper mistake here. So what I need to do here is the user will give me some output here, sorry, some input here. So I'll just implement a switch here for user's input. I'll just create a do while loop. Okay, and okay. So now the user will give me some input. So I'll just take that input. In what was my variable? It was choice. Okay, so now I now have my choice, so I'll just implement a switch over this choice. Okay, to implement the switch over choice, I'll use the switch construct. And now case one, in case one, what I'm doing, I'm just pushing the element. Okay, so if I need to push the element, what you need to do first is you just need to enter the element first. So let me just print enter the element block. Now you just see in the value of, I think item was the name there. Now what you do, you just call push here with this particular item. Now as we are using a switch case, so we do not want a fall through condition, so we'll use break here. Now for the second case, in the second case, I want to do a pop. I want to do a pop, and I guess I did a mistake. Okay, so in case two, what I'll do is I'll just call my pop function and break to eliminate any fall throughs. Then case three was to check the top. For top also, what I'll do, I'll just I think top was a returnable function. Yes, top was a returnable function. So what I'll do is I'll just see out function call. Tick out break to eliminate any fall throughs. Then a case four. What was case four for us? Case four was for empty. Empty was also a returnable. Okay. So I think here also I'll do as see out. See out what you see out. You just see out the is empty function. And then is empty was is empty only, I guess. Yes, is empty only. Now again a break statement here. Now the next case, case five. What was the fifth case? Fifth case was to print the stack, and I think this was the last one. Okay, just to print the stack also we do not need anything. I think this was also a non-returnable function. Yes, so I just need to call it. So I'll just call it. Okay, and now break. And at the end of every case, we need to provide a default case. If by mistake anybody gives an choice that is not been switched, so my call will go into a errorless code. So I'll just make a default choice also. So I guess we are done here with the coding part. Let me just go through it once, so to check whether my Yes, 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 yes. I just need to end my do while loop also. So to end my do while loop, what I'll do is I'll just check mail while my choices, while I'm getting some choice. While I'm getting some choice, I'll do this. Okay. So I guess everything is okay now. So let me just run this particular code. Let me just run this particular code here. So that's plus, what is the name? Array cpp minus o array implement.cpp. You can know such file. What is happening? Right. I understood what's the error here. I was putting 0 there instead of O. What is happening? Control reaches end of non-void function. Okay, input already declared. Okay, I guess what's the mistake here? I'm just declaring the function and the variable we received. I guess the problem should vanish now. Why is item? Why? Okay. Okay. No problem now. So int PopF control reaches end of non-void function return type. Array. Yeah. Made a mistake somewhere. I'm using it as so. Let me just try it once again. Ah, okay. Finally. So now it is asking for my choice here. Okay. So first of all, let me just check whether my it is empty or not. So it is returning me one. One means true. Okay, that means my correct stack is empty. So let me just try to pop from my this stack, and it is returning me a underflow now. Okay, okay, just let me just change this a little bit. I think this is a bit ambiguous now. Let me just make this like this. Let me just leave it like this only. Okay. Now let me just enter as I was checking. Let me just check whether my array is it is empty. It is running one. Now let's try to pop an element from an empty stack. So it is returning an underflow. It will return an underflow because the stack is now empty. Let me just print this stack. Is also underflow because no element is there. So let me just try to push in some elements. So let me just push in 56 for now. Then again, let me push in some say 65. Then let me just push in one more element. Let's say it is 78. Okay, so let's now again check whether my array is empty or not. So no, it is returning as 0. That means false. The array is not empty. So let me just print the array. Sorry, print the stack. It is 78, 68, 56. I think okay. So now, so now let's try to check whether what's the top element. Top element 78. Okay. Now let me just pop out some of the elements from this stack. So popped element is 78. Let me just check display the is now 68 and 56. Top should return 68 now. So let me just check whether yes 68 is the top. Now let me just pop out the element. So 68 must be popped out and this is the top element now. So popped out element is 68. Let me now again check, and I think why it is underflow. All the elements are inserted. Yes, check print the code. I think in printing some error is there in our code because it is at position 0 also it is returning that it is underflow. Let me just check what mistake I have done while printing the array. This is what I have done. If top is greater than 0, so this should be if top is greater than equal to 0, yeah, because it is an array. So I think the array implementation is clear to all of you. If not, then kindly mention in the comment section, and then we will move on to the linked list implementation. While fixed poster button linked list. array is fixed for stack because array in itself is a limited size data structure. Okay, that was also one of the drawbacks of array, as we have already discussed. And in linked list, the size is only limited to the number of nodes that we can create. So that is why the size of the array stack is fixed only in case when it is implemented using array, because the size of arrays are fixed, and vice versa. So now I guess this one's clear. Any more further doubts? Over condition is not there in linked list, am I right? Little bit confused in it. Overflow condition in linked list. What is overflow condition? When the maximum size of the stack will be reached. So in linked list, what we can do is we can just create a node. So there will not be any overflow condition. Correct. So I think this one's clear. So we'll move on to the next part as nobody is asking any doubts here. So let me just. Yes, in array fixed size is there dynamic, but in there is no max size. Yes, in linked list there is no max size because in linked list we are creating the nodes. Whenever we require a new node for the linked list, what we can do is preferably is we can just create one another node from the memory heap using the memory present in the free memory pool. Okay, so there will not be any uh, thing named as limit exceeded, and that's why overflow will not be reached when we are implementing a stack using linked list. Insertion at the beginning, no, insertion at the beginning will not never happen because stack by its principle only it's LIFO, last in first out. So insertion will always take place at the end. Okay, so now for linked list, what we need to do, as in stacks using arrays, this was clear that we needed to uh, create one array. Okay, initialize the top to -1 and then begin our journey of implementation. In linked list, what will happen? This is the thing, this is what a linked list is. So if this linked list is if a stack is being used in this linked list, what will happen? If the current elements are 1, 2, and 3, and if I need to add one more element 4, so what will the first step? First step will be to create one new node. What I'll do is I'll just create one new node, assign the value to this particular node, and then what I need to do is I just need to insert the element at the end, this particular node at the end of the linked list. Because if I'm traversing the linked list now, it will be 1, 2, and 3, and now what will happen? It will be 1, 2, 3, and 4. But what while I am popping, so what I need to do is I just need to move on to the end of the linked list. When I am at the end of the linked list, what I'll do, I'll just remove this particular link, and this will be removed. What I need to do is I just need to implement a deleting a node, this particular algorithm that we have already discussed while we were discussing linked list. What I need to do is I just need to delete the last element from the linked list while pushing. What I need to do is while pushing, we need to implement insert at the end. We need to implement insert at the end funda. While popping, what we need to do is we need to implement delete at the end. Top also, what we will do, we will just move on, traverse the linked list wholly, and then when we are at the end node, what we will do, it will just return the value of the that particular node. Is empty means no nodes are there in the linked list. Okay. And print linked list, print stack will just be iterating towards the end of the linked list using next equals to next connect. Okay, node connect, and then printing all the node values. This is how we will implement a link stack using linked list. What we need to do, we just need to, for push operations, we will insert a new node at the end of the current linked list. For pop operations, we will delete the last node of the linked list. For top, we'll just print the value present at the last node. And for displaying, what we will do is we will just traverse the whole linked list and print the values. No stack के stack के थ्रू बताना, लाइक नल ऊपर आएगा ना तो ट्रैवर्स कैसे करेंगे? नल ऊपर क्यों आएगा? डायनामिक are not clear. I think dynamic, your concepts of linked list is not clear. See, how do we traverse a linked list? What we do is, there is a term named as head of the linked list. This points to the first node. What we do is we just first reach to the head. Then for next traverse, what we do is we just traverse using this thing. Next equals to current node ka next. So what this will store is, this will store the value, that is address that is stored at the next of this node. Again, what it will store the value stored at this particular next of this node. And until when we need to iterate this, until my next does not equal to null. And if my next equal to null, this means that the address that is stored here is of not of a node, but it is storing a null address. That is the end of the लिंक लिस्ट. डायनेमिक इज आस्किंग घुमाओ, क्योंकि इसको 90 डिग्री घुमाओ, 90 डिग्री घुमाओ, लिंक लिस्ट को घुमाओ. क्यों घुमाएं डायनेमिक? आई एम नॉट अंडरस्टैंडिंग व्हाट यू आर आस्किंग. इफ आई, अगर हम इसको घुमा भी देंगे तो इट विल लुक समथिंग लाइक दिस. आई डोंट थिंक एनीथिंग चेंजेस. हेड इज हियर, the last node is pointing to null. I don't think anything is there. See, just look into my concepts, what I'm trying to do here. See, these are the functions that I need to implement: push, pop, top, and all. Okay, now what will happen, this is my linked list. Suppose this is my linked list. Current head is pointing here. If I need to push an element, so if it is a stack, it will follow LIFO, that the element will get inserted from the last. So what will happen is, I'll create my new node here. It will point to null. Then what I will do is, I'll just change the link of the previous last element, last node, to my current. That means whichever node was pointing to null, I'll just make that node next point to my new node. This is what I will do. And previously this node was this one, means it was pointing to null. Okay, we will not insert in the beginning. Okay, you can also do insert at the beginning, dynamic. Okay, then we have to just look to the stack from the opposite direction. Then you will also pop from the beginning only. सी बिगनिंग एंड से मतलब नहीं है डायनामिक. देखो मतलब इस चीज से, अगर ये स्टैक है तो इसका इंसर्शन एक ही साइड से होगा, डिलीशन भी एक ही साइड से होगा. आई विल नॉट बी टचिंग दिस पर्टिकुलर साइड, and this particular side will be blocked for me. Okay, so So either you do from the beginning or do from the end. Okay, you just have to stick to it. If you are implementing a stack wherein you are inserting from the beginning, so you will also delete from the beginning only, and you will never touch the end part. If in my case, what I'm doing, I'm inserting from the end and deleting from the end. So what I'll do is, for me, the beginning part will be blocked. I will never touch the beginning part. Okay, what stack means is, you can either pile the things like this, or you can either pile the things like this. In both, here the top will be this one, here the top will be this one. So my dynamic. So now I think for people who have comfortably understood what was linked list and how to insert at the end or at the beginning, as dynamic is saying, so implementation of stack using linked list is quite easy. We just have to implement deletion at the end for pop, insertion at the end for uh, push operations. And as dynamic is saying, if you are touching the beginning part, you will delete from the beginning and insert from the beginning, nothing else. Yes, yes, dynamic. If you are concerned with beginning, you will all perform all the operations at the beginning. If you're concerned with end, you will perform all the operations at the end. That's the thing. So let me just write the implementation now. I think this is clear for most of you. So what I'll do is, I'll just create one linked list and perform insertion at the beginning or insertion at the end to implement the stack. Nothing much, nothing more. Just see, I have just modified the code for code of linked list. Okay, so let me just create stack ll.cpp. So now see what I'm doing here. As in the linked list funda, what we were doing, we were creating one node with a data element, and one was the address element. Here also I have created a class that is named stack node. Previously it was named node. As I'm implementing a stack, I have just renamed it to stack node. So now it has two components. One is the data component, one is the address component, as I was discussing here. So the structure of my node will be something like this. The first part will be storing the data. This one will be storing the next, that is nothing but the address of the next node. Okay, and this is named as stack node. This is named as stack node. Now what I'm doing is, I'm just using a utility function to create a new node. So what I'm doing is, I'm just passing data to this particular function, creating one new node using this particular line. Okay, what I'm doing is, I'm just creating one new object of this particular class. Okay, and now I'm initializing the values of the class members, data to data, that is passed to the particular function, and next to null. Now I'm returning this particular node. I have also created one is empty utility, wherein I'm checking whether my root is null or not. If my root is null, what does it mean? If my root is null, my root is, that is head is null. I am not mentioning here head. I am naming it to root. Okay, that is what I am doing. Whatever was head in my linked list, I am named it to root. If my root is pointing to null, what does it mean? It means that not a single node is there in my linked list. That's why my head is not pointing to any node, but to a null value. And this is the case when my stack is empty. So that's why, if my stack is empty, what I'm printing, I'm just checking whether my root is pointing to null or not. Now for pushing, what I'm doing, I'm just creating See what I have done. I am just creating one new node with the particular data using this particular utility here, using this particular utility. Using this particular utility down here, using this particular utility, what I am doing, I am just creating the uh, uh, new node. Okay, so what I am doing here, I am just creating a stack node variable of type stack node, and I am using that new node utility function to create a new node. Now what I'm doing is that stack nodes next is pointed to by null. So what I'm doing is I just pointed it to the root. Okay, so I have implemented a, as dynamic was saying, from the beginning, insert from the beginning here. So now I'm returning and the root is now pointed to stack node. So what I'm doing here is, I'm doing just one simple thing. First of all, what I'm doing, suppose this is my current linked list. Okay, this is my head or root. As in this case, I am creating one node initially pointing to null. Now what I am making, I am making it to point to the first element, and now making my root to point to the new node. So I am inserting the element at the beginning, as dynamic was saying. Okay, now I think this is clear. Push is now clear. And while pushing, I do not have to check whether overflow condition will be reached or not, because we are dealing with linked lists and memory pool is larger here. While pushing, what I'll check, pushing, we will have to check whether my stack is empty or not. So for checking, what again I am checking the same thing what I was checking here is empty. I am calling this particular utility. Okay, and then doing the necessary things. And for returning, what I'm doing, I'm just making one temp variable point to my root. Then I am making my root next equals to current root, and then popping the element. So here what I am doing is, what I am doing is, this is, if this is my linked list, what I am doing is I am creating my temp to point to the element that is pointed to by root. Okay, root is pointing to the first element. Now I'm making temp to point to the first element. Next, what I am doing is I am making a root point to the root next. So I'm deleting this particular link and making root point to this. So now if root is pointing to this particular link, so what is happening? Linked list starts from here now. Now what I'll do, I'll just delete this particular node. Okay. So this is only I'm doing. What I'm doing is I'm creating one temporary node, making it point to the value that is pointed to by root, then making root point to the next node, and then popping out the element by printing out the temp data and using the free function as I have already discussed. This deletes out the memory that is occupied by a particular node, occupied by a particular object. Okay, so this will free that memory for us. Peak is nothing but top here. Peak is nothing but top. I have not used top because of the prior thing that happened. Okay, so peak is nothing but top. So what I'm returning, I'm just checking whether my top stack is empty or not using the is empty utility that I have already designed previously. And if it is not the case, then I'm just printing whatever the data that is pointed to my head. Okay, and this is the main. In main, what I'm doing, I'm just creating one head initially being pointed to by null, pushing the elements, then just calling out the functions. Just calling out the functions. I guess no problem should be there till here. समझा है सर, क्लास की ज़रूरत क्यों है? लाइक नोड क्लास अलग, स्टैक नोड अलग. Stack node new into data, what does stack node means? See, stack node here is the name of my class. See, stack node is the name of my class here. Okay, and new node is the name of the utility function that I have created here to create one node. Okay, so insertion at the end possible है वैसे. Yes, insertion at the end is also possible. Dynamic class की जरूरत क्यों है? node class अलग, stack node अलग. Stack node अलग, where I have not created, I just created one class. See, this is only the node. If I just rename it as node, this is only what node is. Okay, I'll just rename it as stack node because I'm implementing a stack using this particular thing, nothing else. So dynamic, I think your question gets resolved here. So if you do not have any doubts till here, we'll end this session here for stacks. Okay. Okay, so one more thing. There is also, as I have already used it in stack. mm, Reverse one. Think I don't think I have coded it. No. Print link list, delete link list, find length. See, in C++ and Java also we get one utility named as stack only. STL also you can say it. It is also STL only. So what you can do is you can just use it as we were using vectors or any other STL, and all the functions that we just defined, push, pop, top, is empty, are all already being coded for this particular utility. So what we need to do is we just need to create one variable of that particular stack type. Okay, and then just use push pop any function that you need to use, so that you do not need to code this entire utility every time you are trying to use a stack. So this is one of the things that I needed to discuss, that in C++ and Java both you get stack utilities, okay, wherein you get pre-coded forms of stack, so you do not need to implement stack every time you need to use stack. Okay, node pointer means a pointer of type node, that only, nothing dynamic. That asterisk means pointer. I think you are not familiar with C or C++ coding, that's why. This means that I am creating one pointer. See, let me just explain this for a little bit here. See, what does it mean? Suppose suppose I have a variable named a, and I am storing a equals to 23. Let's suppose. So a is contained in the memory. Let's suppose at a memory address of b2xx. So this is the address of this thing, this particular variable. So now if I define something like this, int asterisk b equals to address of a. So what is b? B is a pointer. B is a pointer storing address of a variable that stores int type data. That stores int type data. This is the meaning of this particular line. What does line means? That b is a pointer that stores the address of A, and A stores data that is of int type. Okay, so now what is here? It is here as node asterisk something. Let's suppose it is something, I think stack node only. So node asterisk stack. So what does this mean? This means that stack is a pointer which stores the address of some other variable which stores data of type node. This is only this means. This means that stack is a pointer that stores the address of a variable which in turn stores data of type node. This is what is meant by this particular like diagram. If it is clear, we'll end the session here today for today. Tomorrow we'll start off with queues. Okay, and then I'll just finish queues, okay, in shortly, because if stacks are clear, queues are simpler. Okay, can be implemented in the same fashion, and then we will move on to some of the uh, questions that can be solved using stacks and queues. Okay, functional return type in stack is a pointer return type. Yes, you can guess it like this. Okay, if stack is a pointer return type, it is returning a pointer, or you can just say it is returning an address. It is returning an address, and to store that address we need a pointer. Okay, that's why function return type is stack node is a pointer return type. See, if it is returning an address, okay, so address is stored using pointer variables. Okay, so if I'm returning the address, so I need to return pointer to particular address. So that's why I'm returning the pointer. In simpler term, you can say it, you can see it like this. Okay, okay, if it is clear, then we'll end the session today. Tomorrow we'll be discussing some important questions on stacks, okay, and also be discussing queues in detail. So let's finish the session here. Thank you. So if you need to contact anybody of the team, you just need to join the Telegram and the Discord server, and the team will help you out dynamic. Okay, and post your doubts there. The attendance link is being shared to you in a short while. Just wait for it.